What if one of the biggest changes in Earth's history is happening right now, and almost nobody can see it? Deep beneath the ground in East Africa, forces that have been building for millions of years are slowly pulling an entire continent apart. Roads are cracking, valleys are widening, volcanoes are rising. Scientists say that one day this process could create a brand new ocean. It sounds like something from a disaster movie, but this is not fiction. It is one of the most remarkable geological events happening anywhere on Earth today. The most surprising part is that we are living through the early stages of it. The question is not whether Africa is changing. The real question is how fast it is happening and what it could mean for the future of our planet. This is not a story about a sudden catastrophe. It is a story written over millions of years, one that continues every single day beneath our feet. Scientists have spent decades studying a massive geological feature known as the East African Rift System. Stretching for thousands of kilometers from the Red Sea through countries like Ethiopia, Kenya, Tanzania, and Mozambique, this enormous network of valleys, volcanoes, and faults marks one of the few places on Earth where a continent is actively splitting apart. For generations, these landscapes amazed explorers and local communities. Towering cliffs, deep valleys, steaming hot springs, and chains of volcanoes created scenery unlike anywhere else on Earth. But only in the last century did scientists begin to understand what was really happening beneath the surface. The Earth may seem solid, but its outer shell is broken into giant pieces called tectonic plates. These plates are constantly moving, although the movement is incredibly slow, usually only a few centimeters each year. That might seem insignificant, but over millions of years, those tiny movements reshape entire continents, build mountain ranges, and open vast oceans. Africa itself sits on one enormous tectonic plate, but researchers now know that this plate is gradually breaking into two smaller ones. The larger section is called the Nubian Plate, while the eastern portion is known as the Somali Plate. Between them lies the East African Rift, a region where the Earth's crust is being stretched little by little. But that wasn't the biggest surprise. Scientists discovered that this stretching is not happening only at the surface. Deep underground, powerful forces inside Earth's mantle are slowly pulling the crust apart from below. Hot rock rises toward the surface, weakening the crust until it begins to crack. As those cracks grow larger, blocks of land sink, creating the long valleys that define the East African Rift today. One of the best places to witness this process is Ethiopia's Afar Depression. Here, three tectonic boundaries meet in one extraordinary location. Geologists call it a triple junction because the Nubian Plate, the Somali Plate, and the Arabian Plate are all moving away from one another. Few places on Earth provide such a clear window into how continents eventually split apart. Standing in the Afar Depression feels like stepping onto another planet. The landscape is filled with hardened lava fields, colorful mineral deposits, steaming vents, and active volcanoes. Temperatures often climb above 45 degrees Celsius, making it one of the hottest inhabited regions on Earth. Yet beneath this harsh environment lies one of geology's greatest laboratories. Then something happened that captured worldwide attention. In 2005, a dramatic series of earthquakes struck Ethiopia's Afar region. Over just a few weeks, the ground suddenly cracked open. A giant fissure stretched for more than 50 kilometers across the landscape. In some places, the ground moved by several meters. To local residents, it appeared as though the Earth itself was tearing apart. News headlines around the world quickly claimed that Africa was splitting in two. While the images were astonishing, scientists urged caution. The crack was not the beginning of a continent breaking apart overnight. Instead, it was a visible reminder of a process that has been underway for tens of millions of years. The earthquakes allowed magma from deep below the surface to force its way into the crust, pushing the land apart in a matter of days instead of centuries. What happened next changed how scientists viewed continental rifting. Using satellites, GPS instruments, and seismic sensors, researchers carefully measured every movement. They discovered that the crust had stretched by several meters during the event, providing one of the clearest observations ever recorded of a continent actively pulling apart. It was like watching millions of years of geological change compressed into a single moment. Even more remarkable, the event confirmed theories that geologists had debated for decades. Instead of continents splitting through one massive crack, they break apart through countless smaller events spread across millions of years. Earthquakes, volcanic eruptions, and underground magma intrusions work together, slowly weakening the crust until a new ocean basin can eventually form. But the story did not end in Ethiopia. Across Kenya, Tanzania, and other parts of East Africa, scientists continued finding evidence that the rift system remained active. Sensitive GPS stations detected tiny movements every year. Although most were only a few millimeters to a few centimeters, the pattern was unmistakable. The two sides of the continent were continuing to drift apart. To most people, these movements are impossible to notice. You could stand in the same place every day for your entire life and never see the land moving, yet the instruments never stop recording. Year after year, they reveal the same silent motion, proving that the forces shaping our planet are still at work. And as researchers gathered more evidence, they began asking an even bigger question. If this slow separation continues for millions of years, could East Africa eventually become a completely new continent? And could seawater one day rush into the widening rift, creating an entirely new ocean where dry land exists today? The answers would force scientists to rethink not only Africa's future, but the future of Earth's ever-changing surface itself. If the idea of an entire continent splitting apart sounds impossible, it is because our brains are not built to understand geological time. Human history stretches back only a few thousand years. Civilization, as we know it, is just a tiny moment in Earth's 4.5 billion-year history. The forces reshaping Africa move so slowly that they are almost invisible, yet over millions of years, those tiny movements become powerful enough to redraw the map of the world. To understand why this is happening, we have to look far beneath the surface. Earth is made of several layers. The center lies an extremely hot inner core surrounded by a liquid outer core. Above that is the mantle, a vast layer of hot rock that slowly flows like thick syrup over enormous periods of time. Finally, on top sits the crust, the thin, solid layer where we live. Although the crust feels stable, it is actually floating on the slowly moving mantle below. Heat escaping from Earth's interior creates giant convection currents within the mantle. As hot material rises and cooler material sinks, these currents push and pull the tectonic plates resting above them. This process has been shaping our planet for billions of years, creating mountains, triggering earthquakes, and opening entire oceans. But that wasn't the biggest surprise. Scientists now believe the East African Rift is one of the few places where we can actually watch a continent begin to break apart. It is like seeing the earliest chapter of a story that has already happened elsewhere on Earth, millions of years ago. The Atlantic Ocean did not exist. North America, South America, Europe, and Africa were once joined together in the supercontinent Pangaea. Around 180 million years ago, powerful forces deep inside Earth began pulling those landmasses apart. At first, only small cracks appeared. Volcanoes erupted. Earthquakes became more frequent. Slowly, seawater flooded into the widening gap. That gap eventually became the Atlantic Ocean. Today, every time you look at a map, you are seeing the result of a continent splitting apart over millions of years. Scientists believe East Africa may be following a similar path, although every rift evolves differently. One of the strongest pieces of evidence comes from space. Modern GPS satellites can measure the movement of Earth's surface with astonishing precision. Stations placed across East Africa show that the Somali plate is gradually moving away from the Nubian plate by only a few millimeters to a few centimeters each year. But that may sound incredibly slow.
Oh yes.
Your fingernails grow faster than the plates move. Yet if that motion continues year after year, century after century, and million after million years, the accumulated distance becomes enormous. What seems insignificant during a human lifetime becomes enough to reshape an entire continent. Then researchers uncovered something nobody expected. The movement is not perfectly smooth. Instead of drifting apart at a constant speed, the plates often remain locked together while stress builds beneath the surface. Eventually, that stress becomes too great and the rocks suddenly break. The result is an earthquake. This explains why East Africa experiences frequent seismic activity. Most of these earthquakes are small, but together they reveal that the crust is constantly adjusting to the forces pulling it apart. Volcanoes tell the same story. As the crust stretches and becomes thinner, molten rock from deep inside Earth finds easier paths toward the surface. This is why the East African Rift contains some of the world's most active volcanoes. One remarkable example is Erta Ale in Ethiopia. Unlike many volcanoes that erupt only occasionally, Erta Ale has hosted one of the world's longest-lasting lava lakes. Scientists studying this volcano gain valuable clues about the magma rising beneath the rift. The process is weakening the continental crust. Farther south, another volcano has captured scientists' attention for a completely different reason. Aldonyo in Tanzania is unlike any other active volcano on Earth. Instead of erupting ordinary lava, it produces an unusual type called carbonatite lava. Freshly erupted, it appears dark rather than glowing bright red because it erupts at much lower temperatures than typical lava. Within hours, it changes color as it reacts with the atmosphere. Its unique eruptions remind researchers just how unusual the geology of the East African Rift truly is. But perhaps the greatest clue lies hidden beneath the surface. Using seismic waves generated by earthquakes, scientists can create images of Earth's interior, almost like a medical CT scan of the planet. These studies reveal a vast region of unusually hot material rising from deep within the mantle beneath East Africa. This rising mantle plume is believed to play a major role in stretching and weakening the crust from below. The truth was becoming even more convincing. The earthquakes, volcanoes, satellite measurements, and underground imaging all pointed toward the same conclusion. They were not isolated events. They were different pieces of one enormous geological process that had been unfolding for tens of millions of years. One important question remained unanswered. Exactly how long will it take before East Africa completely separates? The honest answer is that no one knows with certainty. Most geologists estimate the process will require millions of years, possibly 10 million or more, before a fully developed ocean forms. Nature does not follow a precise schedule. The rate of movement can change, volcanic activity can vary, and new geological events may alter the course of the rift. That uncertainty is exactly what makes the East African Rift so valuable to science. It is the only place where researchers can observe the birth of a future ocean while it is still happening. Every earthquake recorded, every volcanic eruption studied, and every GPS measurement collected adds another piece to one of the greatest geological puzzles on Earth. And as instruments became more advanced, scientists began noticing signs that the changes occurring beneath Africa were even more complex than they had first imagined. What they discovered next would challenge long-held ideas about how continents break apart and reveal that Earth's surface is far more dynamic than anyone once believed. For many years, scientists believed they had a fairly simple picture of how continents break apart. The crust stretches, cracks form, volcanoes erupt. Eventually, the land separates, and a new ocean is born. But as researchers gathered more data from East Africa, they realized the real process was far more complicated. Every new discovery seemed to raise another question. One of the biggest breakthroughs came from satellites orbiting hundreds of kilometers above Earth. Unlike earlier generations of instruments, modern satellites can detect tiny changes in the shape of the ground with incredible precision. They can measure whether the land has risen, sunk, or shifted by just a few centimeters over vast areas. When scientists compared years of satellite observations, they found something remarkable. The East African Rift was not changing evenly. Some regions were stretching faster than others. Certain faults remained quiet for years before suddenly becoming active. In other places, magma was silently moving beneath the surface without producing a single volcanic eruption. It was like watching a giant machine with thousands of moving parts, each operating on its own schedule. Then researchers uncovered another surprise. By combining satellite data with GPS measurements and earthquake records, geologists discovered that magma often plays a much larger role than they had once believed. Instead of the crust simply cracking under pressure, rising magma can force its way into tiny fractures deep underground. As the molten rock spreads, it pushes the surrounding crust apart from the inside. This process is known as a magma intrusion. Sometimes it happens quietly over months. Other times it occurs in just a few days, accompanied by hundreds of small earthquakes. The dramatic 2005 event in Ethiopia is one of the best studied examples. Scientists concluded that a long sheet of magma had injected itself into the crust, forcing the land apart and creating the spectacular surface fissures seen around the world. But that wasn't the only evidence. Across Kenya, the Great Rift Valley tells the same story on an enormous scale. Towering cliffs rise hundreds of meters above broad valley floors. Lakes fill deep basins created as blocks of crust slowly sink between parallel faults. Some of Africa's most famous lakes, including Lake Tanganyika and Lake Malawi, their existence to this ongoing geological process. These lakes are more than beautiful landscapes. They are windows into Earth's past. By studying the sediments at the bottom of these lakes, scientists can reconstruct millions of years of climate change, volcanic activity, and tectonic movement. Each layer of mud acts like a page in Earth's history book, preserving clues about how the continent has changed over vast stretches of time. The truth was becoming even more fascinating. The East African Rift is not just changing the land. It has also shaped the evolution of life itself. Many researchers believe the shifting landscapes, changing climates, and expanding grasslands created by the rift influenced the evolution of early human ancestors. As forests gave way to more open environments in some regions, ancient hominins faced new challenges that may have encouraged important adaptations, including changes in movement, diet, and survival strategies. While many factors influenced human evolution, the rift's changing environment is considered one possible contributor. Then came another remarkable discovery. Scientists studying gases escaping from volcanic regions found that the mantle beneath East Africa is chemically different from surrounding areas. This supports the idea that a deep mantle plume, enormous column of unusually hot rock rising from deep inside Earth, helping drive the rifting process. Yet not every scientist agrees on exactly how this works. Some researchers argue that the movement of tectonic plates is the primary force pulling the continent apart, while others believe the mantle plume plays the leading role. Many now think both processes work together, making the East African Rift one of the most complex geological systems on the planet. That scientific debate is healthy. It shows that even after decades of research, Earth still holds mysteries that have not been completely solved. Meanwhile, life continues across the rift. Millions of people live in cities and villages throughout East Africa. Farmers cultivate fertile volcanic soils. Wildlife thrives in national parks that attract visitors from around the world. Most residents will never directly notice the slow movement beneath their feet because it happens over timescales far longer than a human lifetime. Still, the rift occasionally reminds everyone that it is active.